Now, there are different ways of denoting a set. The book is actually going into this a lot more than I am. They actually give a lot of different notation with sets and set theory. The way we will denote a set is just using these curly braces. Basically, you draw these curly braces and you list the elements in the set, separating them by commas, like what I did over here. So here we have a set of the numbers 1, 2, 3, and 4. Here we have a set of just 1, 2, and 4. I mean, there are other ways to denote a set. This is actually what they call the roster method, because you're listing all the elements. Kind of like the roster of a class tells you who's in the class. Now, when there are too many elements to list, though, that's where this ... notation comes into play. When there are too many elements, but you want to list enough elements so the pattern, so it's easy to see what the pattern is. The underlying pattern, that is. So for instance, if you look at this set of what we call the natural numbers, which really for us are the positive integers, right? There's way too many to list. We can't list them all, right? You know, the list would never end. So what we use is we use this ... notation. But notice what I did was I listed a few elements, but now you can see what the pattern is, right? The first one is 1, then we have 2, next comes 3, next comes 4. So what would come next? Well, 5 would be next, right? We keep increasing by 1. So we would have 5, then after 5 would be 6, and after 6 would be 7. So you can see the underlying pattern. Now, you can't list all the elements. There's infinitely many, which basically means you would never be able to list them all. You would run out of time, so to say. The list would never end. Okay, so that's what the natural numbers are. I should say this also. Some math books and some authors allow 0 to be a natural number. Our book does not do that. Now, why? I honestly don't know. Maybe it's just personal taste on the authors, but 0 for us is not a natural number. But from the natural numbers, you can form the set of integers. I mean, all you do is you throw 0 in there, and then you just throw in the negatives of the positive integers. So we have our set of integers denoted by this funny looking Z. Here, actually, we have that double ... notation. But you can still see the pattern, though, because if you start at 0, for instance, right, then you go -1, then -2, then -3. But then the next element here would be -4. Then after that, it would be -5. After 3 here, right, 1, 2, 3, and then you have 4, then you would have 5, then you would have 6, and so on. So hopefully you can see the pattern. I know this is kind of a funny way to write it, so what I did was I rewrote the set this way. These two sets are the same because they contain the same members. The same elements are in the set.